All right, so for our last reaction, we are going to add our 30% concentrated hydrogen peroxide to this beaker with another solution, and we're going to react it with a catalyst. So after doing the gizmo, think about what should happen upon the addition of a catalyst to this reaction. Will it speed up the reaction? Will it go faster? Will it go slower? Especially in comparison to the room temperature and the high temperature videos that you just watched. So to start us out, I'm going to put 20 milliliters of concentrated hydrogen peroxide into this beaker here. And then I want my catalyst that I'm going to use to not dissolve. I want to make sure that it just reacts with the hydrogen peroxide in there. So what I'm going to do is actually add this super saturated solution of potassium sodium tartrate, PST, and this is saturated. So I'm going to add this to my beaker as well. I'm going to put in 60 mils. And so because this is super saturated, what you're going to see when I add in the catalyst is that it's not really going to dissolve super well because there's already so much dissolved in the solution. So the catalyst that we're going to be using for this reaction is cobalt 2 chloride. Let me open this up so you can see what it looks like on the inside. It is absolutely gorgeous color pink, magenta E. Take a look at that. So I'm just going to add in a small amount of this catalyst to my beaker right here with my hydrogen peroxide. Give it a little swirl. And just like I said, notice how it's not dissolving super well because that PST is so saturated. So we're going to let this run. I'm going to start our timer right here. I'm going to leave the timer off the screen so you can watch the reaction up here. Let this run. If you look closely, you can already see some bubbles forming at the bottom. All right, more bubbles forming. So think about that decomposition reaction. We're starting with hydrogen peroxide. We're getting some gas right there. So think about what that gas is made of. Notice the interesting color change as well. You can see more of that catalyst dissolving into solution as those bubbles are bubbling up. If you listen carefully, you can hear the bubbles. That's how quickly they're being produced. If I put my hand close to it, it feels super warm. So think about what that means, exo or endothermic. Now here's the cool part. Watch closely. Look at that. again, if I put my hand up over here, it's radiating a lot of heat up here. But take a look at our solution. It's back to that pink color. So think about what that could mean. We started with our catalyst and potassium sodium tartrate, PST, our catalyst, hydrogen peroxide. And what we're left with here is just a pink solution. So what's in that pink solution? Well, it has to be our catalyst, and it's just the products of this reaction, water. That oxygen gas that was produced is now back up into the air, so the only thing left in here should be our water and our catalyst. So this reaction really nicely shows the recovery of that catalyst. We started with the catalyst at the beginning. We got it back out at the end. You can see that gorgeous pink color telling you that our catalyst is still present there. So this helps the idea that catalysts are recyclable. If I let that water evaporate out, I'm going to get my catalyst back out in the end, and I could use that catalyst again in another reaction. That is the coolest thing.